Hello, welcome. This is the Freedom Research Podcast, and my name is Hannes Saar. My guest today is Professor Ian Plimer, a geologist from Australia. He is an Emeritus Professor of Earth Sciences at the University of Melbourne, where he served as the Professor and Head of Earth Sciences for almost 15 years. He has also been a Professor at the University of Newcastle and the University of Adelaide and elsewhere, as he has a long career behind him. He has published more than 130 scientific papers and 15 books, and was one of the editors of Encyclopedia of Geology, for example. And it is also well known that Professor Plimer is not very impressed by people who proclaim that there is an imminent climate crisis or that it is our fault that there is a global warming and we're doomed because of it. So it is very nice to see you, Professor Plimer. I hope I introduced you somewhat. You can add something, if you will.
Well, thank you for having me, Hannes. Yes, I'm one of those people who had a very traditional education. I've travelled an enormous amount as a geologist. We are taught to observe and to think about the observations, to see if these observations are in accord with previous observations. And it's through that training and those eyes that I look at this current fad of climate change. And it's got nothing to do with science. It's got nothing to do with the environment. It is a mechanism whereby unelected elites are attempting to control us. And they attempt to control us by using science, by using mathematics, by telling us that the world is in crisis, that the world is going to end. And we've had thousands of years of people telling us the world's going to end. And if just one of these predictions was correct, we wouldn't be here. So as a scientist, I've been trained to be sceptical about everything, to be sceptical about even what I write myself. And I've had the great pleasure once of destroying much of my research by writing new work that I've done, and to show that work that I did in the 1980s and 1990s was not correct, that I can present better data and a better understanding of the phenomena. And so I've written and criticised myself. And I think that's what science is about. It's all about criticism.
Yeah, exactly. This is you always ask questions, right? This is what scientists actually do. They have to ask questions. Well, they present an hypothesis, and they have to ask questions and try to see if it is it is correct, or can it be falsified. This is basic scientific philosophy.
Well, this is the nature of science, and you might answer one question, but by answering that one question, you create another two questions. And so science is never ending. And we do solve problems, and we do use science. I travel a lot in aeroplanes. I understand how an aeroplane flies. I understand how a wing works. I understand the science behind that, and I'm quite happy to fly in an aeroplane. By the same token, I look back at what's happened on planet Earth, and our understanding probably gets worse as we go back in time, but our understanding of the history of the planet very much tells us what's happening today. And what's happening today is certainly not in accord with what we hear in the media about a climate crisis. We've had climate crises in the past. We had one between about 1280 and 1300 AD, and this is when we moved into the Little Ice Age. We had another climate crisis in about 535 AD, and this is when we came out of the medieval warming into the Dark Ages. These crises were driven by many features, solar features principally, and you've had guests before who are experts in this, driven by solar features, driven by massive events of volcanicity. There are many reasons. And if you really want a climate crisis, then have a period of cooling. This is when we have less crops produced, we have crop failure, we have starvation, we have people under pressure, they get exposed much more to disease, they get exposed to competing rivalries, and we have more warfare. So in today's world, we are living in the best times ever to be a human. We eat, we don't have much war, we have much better medicine, we live a lot longer, and we are having a movement now to shorten our lives. Well, I say, well, this whole climate catastrophic fad is one which is attacking everything that we built up over thousands of years. It will damage us economically, as it's doing now, and it will damage our health and longevity.
So basically, let me ask you this. We have been told that we have a global warming, and we have been told, well, for example, by Mr. Guterres from the United Nations that actually we are in an era of global boiling. And then they declared last year the hottest in Earth's history. So what are your comments on that?
Well, I've been told many things in my life. I've been told there was Father Christmas. I've been told that there were fairies. I've been told, and this was a long, long time ago, I've been told by young women that they love me. So you learn to be sceptical. And I'm not interested in what I'm told. All I'm interested in is the evidence. And to use words like global boiling is clearly absolute nonsense. And that nonsense is evident. You've only got to go and look at the sea. You've only got to look at the oceans, and you can see there is no boiling. So this is clear hyperbole to try to frighten us, because by frightening us, you then don't have to present evidence. You just present the propaganda. So I don't believe what I'm told. And the word belief is not a word you use in science. Belief is used in politics. It's used in religion. But the word belief is not a word of science. Science is married to evidence. And we come to conclusions based on evidence. If we have new evidence, if we reevaluate the evidence, we might change our conclusion. So as soon as someone uses hyperbole, as soon as someone exaggerates, as soon as someone uses the word belief, oh, you don't believe in climate change, as soon as we hear that, I know that we're dealing with propaganda.
So what does the evidence tell us, Professor?
The evidence tells us that the planet's climate has always changed. And those changes have been cyclical, and at odd times the changes have been quite random. Now, the cyclical changes driving climate are tectonic changes, and we get cycles of tectonism every 400 or so million years. We get astronomical cycles, and every 143 million years we are in the wrong address in the galaxy, and we get bombarded by cosmic radiation. We have more clouds build up, we get cooler, and we have an ice age. We also have orbital cycles, and we've known about these for more than 100 years. And during these orbital or Milankovitch cycles, we are closer or further to that great ball of heat in the sky we call the sun. And so at times we will have periods when we're warmer, and at times we'll have periods when we're cooler. Now, those cycles are every 100,000 years, 40,000 years, and 20,000 years. Our 100,000-year cycles currently drive, or are a major driver of climate, putting us closer or further to the sun. And so we have 90,000 years when it's cooler and 10,000 years when it's warmer. And we are in one of those warmer periods now. It's called an interglacial. We're coming out of it. And then very slight perturbations of the sun and other features will change temperature. And we have solar cycles, and these cycles are every 22 years, every 217 years, every 1,500 years, every 10,000 years. And these often overlap. So we have periods of time when the sun is putting out more energy, and periods of time when the sun is putting out less energy. This affects the heat that goes into the oceans. And so we have 60-year oceanic cycles, and we've known about this for thousands of years. The Chinese had calendars based on these 60-year cycles. We can see with these cycles that they have driven crops in places where they've got a long history of climate, such as in China. And then we have other cycles on different scales. We have a lunar tidal node, and this pushes warm water into the Arctic every 18 and a half years. And so when you look at the exploration of the Northwest Passage, we can see that every 18 and a half years that is open. And these cycles have quite a profound effect on humans. So we've got these natural cycles which we can measure and which we've known about for quite a long time. And then we've got other phenomena which we don't really understand very well. A massive volcanic eruption can change climate. And we've seen this a number of times in the past. A big volcanic eruption can change weather. But 70% of the oceans, 70% of the Earth is covered by the oceans. We have most of the world's volcanic activity beneath the sea. That's submarine volcanicity. We have about 1,800 known volcanoes that we see above the ground, but we have millions of them on the ocean floor. These add heat to the oceans, and these add carbon dioxide to the oceans. We just don't know how these drive climate, but we have in the geological literature people thinking about swarms of earthquake in the mid-Pacific Rise and the appearance of the El Ninos. We have swarms of earthquakes which are indicating volcanic activity, and following that we are getting warm blobs in the ocean. A gentleman called Wes Yim in Hong Kong has done quite a bit of work on this. So we have some unknowns there, and we don't know the effect of geological processes on climate. Most of the climate is driven by radiation coming from the sun that affects the oceans. The oceans hold the bulk of the Earth's heat, and a little bit of that heat goes into the atmosphere. But we don't know what's happening in the cooling of the planet, which has been going on for a long period of time, and how that affects climate. It's probably not a driver of climate, but it affects climate. So climate is very, very complicated. It's not based on a simple gas, which I haven't mentioned, and that gas is carbon dioxide. The main greenhouse gas in the atmosphere is not carbon dioxide, it's water vapour. And the main driver of climate is actually clouds. And this has been well known by integrating solar physics with cloud physics, with cosmic radiation, and getting a much better understanding of the radiation coming into the Earth and going out. So we do not have traces of a trace gas that are driving a major terrestrial planetary process. There are other mechanisms driving climate, and it's not a trace gas in the atmosphere called carbon dioxide.
Yes, but, well, does carbon dioxide affect even, you know, a tiny little bit of climate or weather, or
yes,
does it have an effect? Of course
it does, yeah. But it's not going to change climate. The first 100 parts per million carbon dioxide in the atmosphere does have a significant effect, and after that, because it's a logarithmic relationship, the effect becomes less and less and less. Now, as a geologist, we look back in time. If I look back over a short period of time, we can see from ice cores done in Greenland and in Antarctica that every time we've got natural cycles of cooling and warming, as we start to get a warming event, we have temperature rise, and later we have an increase in carbon dioxide. So it's actually temperature that's driving the carbon dioxide content of the atmosphere, not the opposite. And that we know from chemistry. We know that carbon dioxide has an inverse solubility in water. The colder the water is, the more carbon dioxide there is in the water. So if we warm the oceans, out comes carbon dioxide later. There's a lag factor. We know from geological time that we've had 6 great ice ages in the history of our planet. 6 out of these 6 great ice ages started when there was more carbon dioxide in the atmosphere than now. And 6 out of these 6 ice ages were not driven by carbon dioxide. In fact, we've got 3 of these great ice ages were at a time when we had 20% carbon dioxide in the atmosphere. Now, if carbon dioxide is to give us global boiling or runaway global warming, then if we've got a carbon dioxide content in the atmosphere that's 20% compared with the current 0.04%, and we've got ice ages, then clearly it's not driving global warming. If it has a part to do in the atmosphere, it is very, very small. So I'm not arguing that carbon dioxide has no effect in the atmosphere. It does help to keep this planet a little bit warm, but it does not drive climate change. Okay. There are other factors that drive changes, which can be very, very rapid.
Okay, but I read different kinds of, scientific articles and blogs sometimes, and I just found out from one blog which is called Skeptical Science. By the way, it fact-checked the documentary film just what was released recently. I don't know if you have seen it.
Yes, that's the Durkin film. Yes.
Yeah, exactly.
Well, that blog Skeptical Science is well known. That is run by a gentleman who claims he's a climate scientist, but he's really a sociologist. He is unemployable and he lives in universities funding climate science. That is a bogus site. It's got nothing to do with skeptical at all. It's a site that is pushing the popular paradigm that humans change climate. And they will criticise everyone and anyone who might have a contrary view. And I know the gentleman who runs it. He's a rather mediocre person academically, and yet he's criticising those people like Richard Lindzen and others who are far superior to him.
Yeah.
So you've got to be very careful of some of these blog sites. These are false sites set up by people to have misinformation, and Skeptical Science is one of those misinformation sites.
Yeah, there are other, of course. I mean, you of course know the Smog blog, which is actually started by PR
if you read the Smog
professionals.
blog, do that, but then read what's up with that. Balance it out.
Yeah, exactly. But I was a bit ironic about the science blog when I talk about skeptical science, because it is so easy to actually, for me as a layperson in that sense, I'm not a scientist, but that was the question. They found or they told that there are at least 30 claims in this Durkin film that have been already debunked. But if you look at each of those claims, you actually can see that they're not based on much. But one in particular that was what you were talking about was that CO2 lags the temperature rise, or this is. This has happened. This is based on the ice core data, and this all is, of course, admitted by the blog itself as well. But now it says that anthropogenic global warming, or CO2 emitted by us, by humans, this is fundamentally different. So I really wanted to check your opinion on that. Can it be somehow fundamentally different, the CO2 that we emit and the CO2 that circulates naturally?
Well, let's go firstly to the ice cores. The first ice core measurements were done on a very broad scale, and it looked as if there was a very good correlation between temperature and carbon dioxide. And then more detailed sampling showed that there was a lag. So it depends upon which data set you like to use. And if you like to use the old data set, you can then say, well, this view of science is wrong. If you use a newer data set, you can say, well, there's a lag. Now, carbon dioxide is a very common gas. All planets, all of the rocky planets have carbon dioxide. All planets leak out carbon dioxide. We've been leaking out carbon dioxide from planet Earth for 4,567 million years. There is no difference in the behaviour of carbon dioxide in the atmosphere between that which humans emit, which is basically recycling carbon dioxide anyway that came from an earlier source, or natural carbon dioxide. Now, the figure given is that 40% of the carbon dioxide 3% of all emissions of carbon dioxide are from human activity, and 97% is from natural. And this is mainly from ocean degassing, but some of it from volcanic degassing and a little bit from respiration. So this is the fundamental question. I have asked climate scientists, and I use that word very loosely, scientists, but I've asked people who live off frightening us witless about climate. I've asked them a simple question. Can you please give me half a dozen scientific papers that demonstrate that human emissions of carbon dioxide drive global warming? I've asked leading scientists at the Scott Polar Institute in Cambridge, one of whom has published 2 major textbooks on climate change. These people have never answered the question. They've obfuscated. I've asked the former chief scientist of Australia the same question. Can you please show me that human emissions of carbon dioxide drive global warming? It has never been shown. And if you could show it, then what you would have to show is that the 97% of natural emissions don't drive global warming. So the whole argument is ridiculous from the start. It has never been shown that human emissions of carbon dioxide drive global warming. And why would we want to get rid of this carbon dioxide? It is plant food. Why would we want to hide plant food? We have had a decrease in atmospheric carbon dioxide from 0.7% when we had the explosion of life 520 million years ago. It has been decreasing. Now it's 0.04%. Where's it gone? Well, it's gone into life. It's gone into limey sediments. It's gone into oil, gas and coal. It's gone into carbon-rich rocks. We have had a natural sequestration of carbon dioxide going on for over 500 million years. If we halved the amount of carbon dioxide in the atmosphere, plants would die and we would have an extinction of life. So if we really want to follow the view of Patrick Moore, who founded Greenpeace, Patrick Moore is a plant ecologist, and he argues we should be putting carbon dioxide into the atmosphere to stop the extinction of plants, because that's where it originally came from. And we've locked it up in limestones, we've locked it up in coal. And he's arguing we should be burning the limestone to make cement and burning the coal for energy to put the carbon dioxide back in the atmosphere to feed the plants. So if you were a true environmentalist, you wouldn't worry about hugging plants, you would actually feed them.
Okay. And, well, you as a geologist probably know it best. How much of those resources that we burn, fossil fuels they're called, how much do we have them? Because this is another thing that has been kind of, always said to us, that we have a problem because they're going to run out.
Well, we've had that argument going on for 60 years now about peak oil, etc. I don't know about in your country, but in my country,
so we don't have any oil.
3,000 years of, we have 3,000 years of coal in Australia. We have about 2,000 years of gas, and we have more than 50 million years of uranium. It will take a very, very long time before we run out, and by then we may be extinct. We may well have different energy systems. I think they're scare campaigns. What we've run out of is common sense. We are frightening people who do not have the basic knowledge. We've run out of common sense, and as part of the argument, they're trying to make us run out of money.
Okay. Well, what is the, rationale or reason behind this energy transition, in your opinion?
I think it's power. I think it's got nothing to do with the environment, because why would we build wind turbines and solar panels and just destroy wildlife and the environment with these? That's got nothing to do with the environment. It's got nothing to do with being green. It's got nothing to do with helping poor people have cheap, reliable electricity. We've had reliable grids and reliable coal-fired and nuclear electricity for a long period of time. So I don't think it's got anything to do with the environment. I don't think it's got anything to do with looking after your fellow man. I think it's where unelected elites have seen a mechanism whereby they can make a huge amount of money and where they can control the average person, yet they don't have to face an election. So this is part of the cancer that we see within the Western world. As a geologist, I do a lot of my work in the third world. I work in South America, I work in Africa, I work in many, many parts of the world where they are impoverished. They are concerned about where their next meal comes from. They are concerned about whether their children can get an education. They are not concerned about putting carbon dioxide in the atmosphere. So this is part of the residual religion that we have in the Western world, where we have sin, where we can have redemption for this sin, where we can buy indulgences, where we can have a holy book, which is the IPCC records, which are nearly 5,000 pages long each time they put out a report. And like all holy books, no one reads it. This is the new global religion of the socialists in Western countries who are trying to have power over us. And this is all about freedom. This is one of the reasons I fight this very hard. The science that they're using is demonstrably wrong, and they are using this science to crush an economy, to take away people's freedoms, and to have a society where people are incapable of having any criticism. Otherwise, I'll be called, as I have been many times, a climate denier. Now, I'm quite happy to have people give me any name, but you must argue the facts with me. Don't use a label to try to keep me quiet. And so the whole movement is one of taking away your freedoms, taking away your money, of having power and never having to face an election.
Yeah. Well, as a geologist, you probably understand a bit better how these technologies that are proposed to fight the, well, imaginary climate crisis, those wind turbines and solar panels, how they're made and what we need to make them. For example, electric vehicles. I have read that you need to work with much more earth than for making a combustion engine vehicle.
Yes, you're quite correct. More. You're quite correct. We use 6 times the tonnage of resources to make an electric vehicle than we do for an internal combustion vehicle. Now, these resources, many of them we haven't actually found yet. This is why we're seeing a massive increase in the copper price. This is why we are seeing a great shortage of certain commodities, such as the rare earth elements. So if you are driving an electric vehicle and you are feeling morally superior to those monsters driving around a diesel or a gasoline vehicle, then you should know that for an electric vehicle, you use a lot of cobalt. That cobalt is mined by slave children in the Congo. These are black child slaves. That cobalt goes to China. China controls the world's cobalt industry. It is the same as China controlling the world's rare earth element industry. If you have a wind turbine, most of the world's wind turbines are made in China, and many of the parts are made using rare earth elements, and China has a control of rare earth elements in the world. If you're buying solar panels, most of these come from China. These are made by Uyghur slave labour. So if you are driving an electric vehicle, then you are a supporter of black child slavery in Africa. If you love solar panels, you're a supporter of slavery in China. If you love the wind turbines, you are quite happy to slice and dice birds and bats, and if they're offshore, to kill whales. You're quite happy to support a country that is looking to increase its standard of living and reduce your standard of living. And I think the Western world has been very stupid by putting its energy systems under the control of China and losing control of their own energy systems. In my country, we have a lot of coal, we have a lot of gas, we have a lot of uranium, and yet we're putting in more and more and more solar and wind systems. We're having to repeat the grid. We're having ourselves completely and absolutely reliable on a foreign power, and I just don't think that's a sensible thing to do. In my country, why would you drive an EV? I very commonly will drive in a day 1,200 kilometres. I can do that with an internal combustion engine. I cannot do that in an electric vehicle. That would take me 4 days to drive that trip, maybe 5 days. I can do it in 1 day in this country. Some countries like Canada, like the US, like Australia, we drive very, very large distances, and we have to. We cannot. In a country like Australia, where we produce minerals and we produce a lot of food, we cannot have a country that's based on EVs. You can't plough hundreds of hectares using an EV. You can't weed using an electric vehicle. You can't harvest using an electric vehicle. You can't then drive the food you produce hundreds of kilometres to where it's going to be used. So the whole concept is one of virtue signalling. It's one of an energy waste. And when you're charging up an EV, what are you doing? You're not charging it up using wind and solar. You're actually using coal and uranium to charge your EV. So the whole exercise is pointless, but it's an exercise where, with a wealthy society, where they have residual Christianity and guilt, people will buy an electric vehicle, enormously priced, but they'll buy an electric vehicle so that they can feel good, so they think they're doing something about the environment. If they really wanted to do something to help the environment, they should leave their electric vehicle alone and go out and live in a cave. Demonstrate by example.
Yeah. This is also something that always puzzles even simple people like me. I mean, it is so puzzling that these people that sometimes tell you that there is a huge problem with climate. There's a huge crisis. They go and fly their private jets to those big conferences to tell you that. And they're saying that we cannot drive our combustion engine vehicles. So this is the hypocrisy built in this is
very
overwhelming.
much so, and that's the hallmark of it all. It's hypocrisy, and it's where the elites want to keep you struggling in your life to pay your bills and buy your food, and they have a great life in their private jets and eating caviar and drinking champagne, and they don't understand, or they don't want to understand, that since we've been measuring temperature, and that's since about 1850, we've had 2 periods of cooling, 2 of warming, and 1 where there's been stasis, 1 where there's been no temperature change. So if carbon dioxide is driving warming, why have we had those periods of cooling? We had one about 100 years ago, and we had one in the 70s. Why do we have these periods of cooling when carbon dioxide is meant to be driving warming? And we are not in a period of global warming. We're in a period where temperature rises and temperature falls on one scale. If you look at another scale, it's the same thing happening, temperature rising and falling, with 10,000 years of warm and 90,000 years of cold. And if you look at another scale, for the last 50 million years, we've been cooling down on planet Earth. And for less than 20% of time, we've had an ice-free planet. We are living in a normal period of time when we've got ice on the planet. And that ice on the planet is telling us we're living in an ice age. And so we have ice ages, and then we have periods of time without ice ages. For most of time, sea level's been higher than now. For most of time, it's been warmer than now. These ice ages come and go. We are in an ice age. We've got ice in the North Pole. We've got ice in Antarctica. And that will disappear. The Antarctic ice has been there for 34 million years. We don't know when it's going to go. So when you look at the history of the planet, we are living in relatively cool times.
Okay, yeah. So I wanted to point out or ask about coal in Australia and relation to China. Coal exports, in the world were the highest last year, and China imports were the highest. And China is building coal plants. At least in 23, it was 2 new coal plants a week. So I don't know if Australia's exports are mainly going to China, probably coal exports at the same time or not.
Well, China imports a lot of coal from Indonesia and from Australia. Australia exports coal to Southeast Asia. We export coal actually to Europe. We export coal to China. We recently gave Ukraine 70,000 tonnes of thermal coal. Now, there are 2 sorts of coals. One coal, which is absolutely essential for making steel. And without that coking coal, we wouldn't have steel on planet Earth. People are saying, oh, you can use methane, we can use hydrogen, but these techniques have not been shown to be economic. So one sort of coal we export, which is coking coal, and that is pretty high priced. Another sort of coal we export is thermal coal, and that goes into power stations. Now, in my country, we have about a dozen power stations, and there's huge pressure to close them down. China has 1,200 coal-fired power stations, is building 2 power stations a week, and India is doing the same sort of growth. So some countries are using coal to grow, and other countries that have grown are now killing off their coal-fired power station. And if we take a step back and look at history, the Western world is where we are because of coal. We could not have developed the Western world without coal, and associated with that is energy, heating, steel making, electricity, medicines, plastics, and it's a very, very long list of about 6,000 chemicals we use in our daily life that come out of coal and out of oil. Now there's pressure to stop us growing, to stop us enriching our societies, yet countries like China and India have seen that the way to get your population out of poverty is to have cheap energy. The cheapest energy is from coal. So China is growing in its coal usage. In Australia, we export nearly 750 million tonnes of coal every year around the world. This is top quality coal. Southern Hemisphere coal is much better quality than Northern Hemisphere coal. It's got a lot less ash. It's got a higher calorific value. It's also slightly younger than the Northern Hemisphere coals. It's a much better quality coal. And this is why we have a big coal exporting industry in Australia. Now, the hypocrisy of it is in Australia is that we have pressure to close down coal mines, pressure to close down coal-fired power generating systems. We've closed many of them, yet we're exporting coal. If coal was so bad, we wouldn't export coal, which happens to be our biggest export at present. And we would go broke to save the world, but we're not doing that. So there's massive hypocrisy. Governments earn a lot of money out of coal exports, and they're quite happy to export coal and to starve this country of coal.
Yeah. So another thing I want to follow up is the excavation of resources for those renewables, they're called, or electric vehicles. It has a much bigger environmental impact if you excavate more, right?
Oh, yes, certainly so. I take the example of copper. Now, from Neolithic times onwards, we found copper deposits at the surface. The copper minerals that we found at the surface were bright green and bright blue. They were easily detected. Those deposits have now been found. We are now finding copper deposits at much greater depth. And instead of having copper deposits at the surface containing 10% copper, we are mining copper at depth, which is, say, at 0.5%, 0.5% copper. Now, what that means is there's a much greater volume of waste rock, and what that means is there's a much greater volume of tailings. This is the residue, the waste material coming out of a treatment plant. So by increasing the amount of resources we use for the renewables, we are actually creating a massive environmental problem. But most of these commodities come out of someone else's country. they normally come out of third world countries. So we turn a blind eye to polluting the third world so we can have a good life. Now, you used the words renewable. Renewable energy, the only thing about renewable energy is that the subsidies are renewable. The subsidies just keep coming. If we had no subsidies, we would have no so-called renewable energy. And if we had wind and solar competing on a level playing field with nuclear, with coal, with gas, with hydro, then we probably wouldn't see a wind turbine or solar facility anywhere in the world. Now, with solar, we use silicon. And to make silicon, we have to use a huge amount of energy to convert silica into silicon. And in that, to beneficiate it, we put in a lot of rather noxious chemicals like cadmium telluride. These leach off the solar panels. They go into the soils, they go into water, and they're there forever. With the wind turbine blades, we use a chemical called bisphenol A. That chemical is banned in almost every Western country. It is used as in the resins of the turbine blades. That abrades out of the turbine blades and goes into soils. When the turbine blades has finished its working life, which is not very long, it's about 15 years, we cut up those blades and we put them in the soil, we bury them, we can't recycle them, and so that bisphenol A gets into the soils and gets into the waterways. This is one of the chemicals that's a permanent chemical in the environment. So if you argue that you're an environmentalist and you like wind and solar, basically what you're saying is that I want everyone to pay me money to make it renewable, to have this money coming every year to me, such that I can pollute the soils and the waterways and destroy wildlife. No, thank you.
Yeah, there are probably other examples as well that are, lobbied to be good for environment. For example, biofuels that, making them has a huge effect on rainforests, for example, because you have to cut them down to basically have more soybeans. And so on.
Yeah, well, that's quite right. And that is basically destroying food growing areas for making fuels when we've got plenty of other sorts of fuels. Now, biofuels, also when you burn them, they release carbon dioxide. Biofuels we have used for a very long period of time. So I also think that's probably not a very sensible thing to do.
Yeah, and probably there are other examples. As there are, I wanted to point out or bring to the discussion other examples that have been told to us that are proof of changing climate. So, for example, we have been told that global warming destroys the Great Barrier Reef, and then that the Arctic sea ice is shrinking. But as I can understand, well, you're from Australia, and I recently just spoke to Dr. Jennifer Marhase, who has who has been going to the reef a lot to show or to see how is it doing, and she says that no, it's not actually dying. What are your comments on that?
No, well, I know Dr. Marahasi very well. She's an outstanding scientist. She's just come back from a period of time diving on the Great Barrier Reef and has reported coral bleaching, and that coral bleaching is cyclical, and she's put up a hypothesis that this may well be related to extra low tides where we're getting coral exposed to the air and dies. Now, as a geologist, we look at the Great Barrier Reef. There are many drill holes in the Great Barrier Reef where we can go back in time. Every time we've had a period of cooling, every time we've had a period when sea level has fallen, then the Great Barrier Reef has died. It's come and gone more than 30 times in the last couple of million years. So the absolute characteristic of coral reefs is they appear and then they disappear. Now, we've had reefs on planet Earth for 3,500 million years, and they have never disappeared when it's got warmer. What has happened is coral reefs have actually thrived when it's got warmer. The only time coral reefs disappear is when it's colder, and sea level drops. So that narrative is absolutely and totally the opposite of what we know. And what we know goes back to the times of Charles Lyell in 1833, where he was looking at the origin of coral atolls. That intrigued Charles Darwin, who looked at these atolls and put out a book on coral atolls in 1842. There was a scientist in Australia that drilled some of these atolls in Kiribati and showed Darwin and Lyell's ideas were correct. The French drilling for the nuclear weapons in the coral atolls and the American drilling showed the same. And that is that when we have a volcano that's a submarine volcano, as it subsides, coral keeps growing up and up and up and up and up. So these atolls can be thousands of metres thick, which we've shown from drilling. And that's showing us that if sea level rises or if the volcano sinks, then the coral atoll loves it. Now, we've validated that work with satellite imagery from Indian Ocean and Pacific Ocean atolls, showing that we have, when we've looked at all the atolls, that most of the atolls have got bigger in size. In some places, some of the small atolls have got smaller, and that's because we've used the coral for road base. We've used it for making cement. We've used it for coral rocks for building walls and putting up houses. So virtually every narrative we hear about the Great Barrier Reef is the opposite of what has been measured and what's been known for 100 years. Now, it's the same with the sea ice. We can measure sea ice extent. We've done that from satellite imagery. We can measure the thickness of ice at the poles, and we do that from gravity measurements from satellites. And surprise, surprise, we see that the ice expands in wintertime and the ice contracts in summertime. But what we don't hear are the 150 volcanoes that are beneath the West Antarctic ice sheet, and that is because Antarctica is pulling apart and breaking up, and it's done that before. And that is giving out a lot of heat that's coming from deep in the earth. And so when we hear about icebergs carving off the ice sheets, or when we hear about armadas of ice in the ocean, people don't think of volcanoes. And we know, we've measured them, and we've got active volcanoes. For example, Mount Erebus, we have active volcanoes in Antarctica. And so there's so many areas of science that people ignore when they're trying to frighten us.
Yeah. Well, let's talk a bit about freedom of expression and academic freedom as well. So, first of all, I want to point out that it was quite interesting when we arranged this interview via email. One of the first things you told me was that. You sent me your resume and told me that Wikipedia has got it all wrong, so don't trust Wikipedia, right? So, of course, I went there and checked out what has been written about you in Wikipedia, and I'm just going to quickly read out. It says in the second sentence that there is some sort of a problem with you, that you reject the scientific consensus on climate change, and that you have been criticized by climate scientists for misrepresenting data and spreading misinformation. Well, of course, I'm not surprised. This is what they do. This is how they do it. Every, let's say, real scientist who asks questions today and says that there are some unknowns in your theory, for example, which is propagated by the mainstream scientists, they get such a remark on their Wikipedia page. But I suppose you cannot actually ignore it, or can you? I mean, your own experience.
I do ignore it. If you look at the first or second line of Wikipedia, it has my birth date as the 12th of February, 1946. Well, I was there. Now, on the 12th of February, I didn't exist. They've got my birth date wrong. And if they can't get my birth date, which you can get on common knowledge, if you can't get my birth date, then everything else has got to be ignored. So I don't treat Wikipedia very seriously at all. And if someone wants to quote Wikipedia, I'd just say, well, what's my birth date? Tell me what it is. But as for not abiding by the scientific consensus, well, I thank Wikipedia for telling me that I'm a true scientist. I've never followed this consensus, and the scientists have to use evidence. We don't use what our peers say, but our current scientific system is where we have a consensus. We don't have peer review, we have PAL review, and as a result, we get promotions, we get research grants, and we get recognition. I don't search for that. Being criticised by climate scientists, well, that really worries me, being criticised by those people who are eminently unemployable, and they can only be employed in a climate institute paid for by our taxes to go out there and frighten the taxpayer to death. I don't see that as being a valid criticism, and science is full of criticism. I'm very happy to join people who use evidence, and I'm of the age and stage in life where I don't care what people say. I just use the evidence. I don't need to play the games that you have to play in science, because unless you get research grants, you actually don't get funded in science, and you can't do any work. So the whole system is geared towards people who are following the party line, who are following consensus. And this, to me, doesn't allow for good science. And decades ago, I sat on the Swedish Research Council, the German Research Council, and the Australian Research Council. And in Australia, we had a policy of funding those lone scientists who everyone criticised, but we would fund them because you got better value for money funding a lone wolf than you did funding a whole team of people that all agreed with each other. So science has always been for fools, and it's got its fads and its fashions and its frauds. And we've got a long history of science being funded by governments and going down paths which are fairly useless. And once we had a period of time when science was undertaken by independent people, they were not funded by the governments, and that's when the great discoveries were made. The really great discoveries were made, such as the theory of evolution. This was made by someone who was self-funded. Wasn't funded by any institution. Charles Darwin funded that himself. So I don't have a problem with being criticised by Wikipedia. If they can't get my birth date right, then what else have they got wrong?
Yeah, but I mean, this indicates the problem that we are encountering in the world today. Because, well, of course, it's not just Wikipedia. It's those science blogs or whatever that say that science is basically settled, in contradiction with your, very good explanation what science is. But what they're saying basically that in climate science is settled, and then they use always those ad hominem arguments that, well, for example, Professor Plimer, you are not a climate scientist, you are a geologist, as if, I mean, geologists can't say anything about how the Earth works, but well, they are doing that. They are saying that, and of course they're saying.
Well,
that.
A couple of points on that. Geology textbooks for the last 200 years have been dealing with climate, and one of the great geology arguments we've had for 200 years is: did Europe have an ice sheet covering it? Now, that was a raging argument that went on in the 1700s and the 1800s. All geology textbooks have got a lot of climate discussion in them, and we are the original climate scientists. The so-called climate science now are basically by unemployable mathematicians who create models which are meant to frighten us. We use evidence, and for hundreds of years, climate has been forefront in a geologist's mind. So if we look at an outcrop, if we look at a cliff of layered sedimentary rocks, one of the questions we ask is, what are the climate conditions that led to the deposition of these sands and silts and muds? What was the climate like? And there are clues that are written in stone that we look at. So I reject that. That's simply because people can only use ad hominem arguments. They will not use evidence. They will not use anything to critically evaluate their own thinking. And this whole climate catastrophe crisis has been possible because for the last 50 years, we've been destroying our education system. Young people now don't know the classics. They don't know the fundamentals. They are incapable of arguing. And so we now have a generation of people that use a smartphone, use Wikipedia, use blogs or use social media to get information, but that's not necessarily knowledge. And so we now have a completely dumbed down society where young people are incapable of arguing. And those people who are critical thinkers and capable of arguing get ostracised. And these are generally the people who we are suddenly now realising are of great value to society. For example, people with Asperger's. These people think very differently to me. Yet, and I employ one of these and deliberately because these people think differently, and we need different thinking to be able to actually solve problems. So what we've created is a generation of people who are incapable of solving problems, incapable of thinking, and use electronic media to get an instant answer when in fact a little bit of basic knowledge and going and looking at how that knowledge was acquired might be a better way of learning.
Yeah, exactly. I mean, you cannot get answers from Wikipedia, as we already talked about, but this is the first page to go when somebody is looking for some sort of information. But there are other sorts of ad hominem arguments as well. For example, all of the skeptical scientists who are criticizing the so-called climate science are employed by big oil, we are made to believe. So, of course, it's not like that at all. But I think you have been
no,
also...
of course it isn't. But
you have been also
I would pray to be employed by big oil on a very, very large salary. It's something I've not had in my life. But look, the only ad hominem argument that I would accept and I couldn't argue against is that I drink too much red wine. Now, if someone said that, well, I'd have to say, well, you are right. I do drink too much red wine, but I enjoy it. Yeah. And here in South Australia, we produce some wonderful red wines. I just can't let our agricultural produce go to waste.
Yeah, exactly. I mean, I have had Australian wines in Estonia as well. Very, very nice. Red wines, I love them as well. And I think that you as a geologist have been criticized because you have relationships with mining companies. Oh, wow. A geologist has a relationship with mining companies.
Well, what a surprise. Geology involves doing mineral exploration and involves taking those minerals out of the ground. Oh, what a surprise. We wouldn't have energy. We wouldn't have metals. We wouldn't have anything in today's world without geology. I mean, this smartphone of mine, there are about 70 elements in the periodic table that are in that phone. We have most of the major minerals in the world go into making that phone. Now, if you want to have that criticism, then you should be giving me that criticism from the entrance to your cave. But if you live in the modern world, you are a beneficiary of geology. And that's what geologists do. Yeah. They go out in the bush and they find minerals, which we use.
Yeah, exactly. So what would you say, to kind of sum up this discussion, what is the state of debate or what is the state of academic freedom in climate science today? Is there any?
Yeah, exactly. There has never been a debate about global climate. There has only been propaganda. There has been no academic freedom whatsoever with those who might put out a different view. Now, I was in a university at the time I published the book Heaven and Earth. That was a major international bestseller on climate change, and it was basically the subtitle of that book was The Hidden Science. And I got enormous criticism but I was powerful enough in the university to say, well, I'm sorry, universities are places of free discussion and free will. If you don't like it, it's bad luck. But I think universities now are places where we produce socially engineered clones who are incapable of thinking, incapable of solving problems. And I think we have a serious problem in the Western world. And that is that if you have attacked education, which happened 50 or 60 years ago, then that is taking away one of the great pillars of freedom and one of the great pillars of a democratic society. And that has happened already. And to me, the only solution to that is to have a severe economic recession or depression or maybe even a war, none of which I would want, but I can see the only way out is to have another great leap forward when we have to get out of bad economic times.
Yeah. Well, Professor Plimer, it has been really interesting and very educating, I would say, talking to you. But our time for today has run out. So thank you again for taking this time and explaining.
And thank you for having me.
So this is it from us for today. My name is Anders Sarv. Thank you and see you soon.